Journal bearing. A journal bearing is one which lateral support gives lateral support to a shaft in contrast to axial or truss support. For dry bearing and for many partially lubricated bearing, we may apply the principle of dry friction. The principle provides a satisfactory approximation for design purposes. A dry or partially lubricated journal bearing with contact or near contact between the shaft and the bearing is shown in this picture, where the clearance between the shaft and bearing is greatly exaggerated to clarify the action. As the shaft begins to turn in the direction shown, it will roll up the inner surface of the bearing until it slips. Here it will remain in a more or less fixed position during rotation. The torque M will remain in a more or less fixed position during rotation. The torque remain required to maintain rotation, and the radial air load L on the shaft will be caused a reaction R at the contact point A. L radial force, M required to maintain rotation. Required moment to maintain rotation. And the radial load L on the shaft will cause a reaction R at the contact point A. For vertical equilibrium, R must be equals to L vertical equilibrium R must be equals to L dot R will be tangent to a small circle of radius Rj called the friction circle. The angle between R and its normal component N is the friction angle. It is tangent inverse mu or radius. Equating the sum of moments about A M moment can be calculated L multiplied to L R sinus phi. For a small coefficient of friction, the angle phi is small and the sinus and tangent may be charged with only small error, since we can replace phi tangent phi tangent inverse mu for a small angle m mu L R. The relation gives the amount of torque or moment which must be applied to the shaft to overcome friction for a dry or partially lubricated journal bearing. And the next section is thrust bearing.